Okay, so we have a real-world trig function question here where we've been given the voltage of an electric circuit. So the voltage is equal to 311 by the sine of 100 pi over t. We have a graph of it here, so we can see that the voltage starts at 0, it goes up. We'll see in a second that it goes up to 311, it comes down back through 0, down to minus 311, up back through 0 again, up to 311, and so on like that forever. So the way that the voltage works is that we have positive values and we have negative values, and that just is about the electricity going back and forth, let's say to the power source, to the plug socket or whatever it might be. So two things that we'd be interested in when we have a question like this at the very start is, number one, we'd be interested in the range, the highest and lowest values of the function, in this case the highest and lowest voltages. And the way we find that is we just take the coefficient or the number in front of the trig function, sine function or cos function, and we take the minus and the plus versions of that, and that gives us our range. If the function had a number in front, let's say an a plus, and then we had this trigonometric function, we would have to add that number to these values, and it would lift the graph up or it would lower it down. But in this case, we just have a number in front of the sine function. So the highest and lowest point is minus 311 to 311. And the second thing that I'm interested in is the period. The period is the length of time it takes for the graph to repeat itself. So we start here at 0, it goes up to 311, it comes down to minus 311, and then at 0.02, it's at 0 again and on the way up, increasing its voltage up to 311 again. And it goes on like that forever. So the period is always, now we can read the period from the graph, clearly the period is 0.02, so that's the period. But if we want to work it out just using the formula, the period is found by taking 2 pi, it's always 2 pi, and dividing that by the number that's beside the variable in the question. So the variable is t, it's in the angle here, and so the number beside that is 100 pi. So 2 pi divided by 100 pi is equal to 1 out of 50. So the period in this question is 1 out of 50 seconds, or obviously we can say that that's 0.02 seconds. Now, that means that every 0.02 seconds, or every 1/50th of a second, this starts the process again, or this voltage repeats. It starts at 0 and it goes up again and down. That means that 50 times in 1 second, like if it repeats every 1/50th of a second, then in 1 second it will have this process, or there will be 50 periods, let's say, in 1 second. So that's important for the second part of the question. This process repeats itself 50 times. The electricity goes back and forth between the plus and minus values 50 times in the first second, or in every second rather. Okay, so what were the actual questions that were asked? Well, the first question was, what's the range? And so like we've said, that's from plus 311 down to minus 311. And that's that part of the question. The second part of the question is something to do with the period. So we've already established that the period is 0.02 or 1 out of 50. They're the same thing, a decimal and a fraction. And how many periods are there in 1 second? Well, how many 1/50ths are there in a second? Well, there is 50. Or how many 0.02s are there in 1 second? Well, take 1, divide it by 0.02, and we see that there's 50. So there is 50 periods in 1 second, which is something that we talked about already. Okay, the next part of the question says that we have a table here that gives the voltage correct to the nearest whole number. And what we could do, just for experimental purposes, is we could have a look and see from our graph, could we read some of these numbers? So for example, T6 is the time 0.01 second. Well, 0.01 second, I can see that the voltage is 0. The voltage is also 0 at 0.02 seconds. So let's just pop them in. So that's 0 and that's 0. T of 0, which isn't on our table here, but T of 0, the voltage at the time 0 is also 0. If we look at our graph, we can read that also. That's here. What else could we read? Well, here's our time periods. We have T1, T2, T3. I can see that T3 is the maximum. That's 311. Then I have T4, then I have T5. I can't read any of those values accurately. We'll have to figure out a way of doing that. Then we have T6, which is 0.01. Then we have T7, can't read that. T8, can't read that. T9. T9 seems to be minus 311, the minimum point of the curve. Then we have T10 and we have T11. And obviously T12 is back at 0 again. So T3 is 311 and T9 is minus 311. Well, T3, we can see that it's 311, that's good. And T9 is minus 311. So the question is, how do I get the rest of the values for the table? Well, it's just about figuring out T1, T2, T3, T4, T5, etc. What is their period of time? So if we take T6, for example, as a starting point, we know that T6 is equal to 0.01, and there is 6 periods of time from T0 to T6. So break 0.01 down into 6 equal parts, and each part is 1 out of 600 seconds. So T1 is 1 over 600, T2 is then 2 out of 600, T3 is 3 out of 600, and so on. And so if we put those numbers into the formula one at a time, we can figure out the values for our table. Now, like I said, we've put in a couple of them there ourselves. We'll confirm those when we put in the times. But if we sub in 4 out of 600, we get 269. Sub in 5 out of 600, we get 156. 6 out of 600, now 6 out of 600, 6 out of 600 is the 0.01. So we saw that that was going to be 0. 7 out of 600 is minus 156. And at this point, we could probably fill in the graph based on the previous entries. 156, 269, 311, 269, 156, 0, minus 156. I'm going to guess that it's minus 269, minus 311, and then we're going to start on the way back up again. So it's going to be plus 269 again, and then it is going to be, or sorry, minus 269 again. We're going back up, but we're still negative, and then it's minus 156, and we get back to 0. So the way that we actually did it was we put the numbers into the calculator, but you know, there's a bit of common sense here as well, that we can see that the graph repeats itself over time. Okay, now we can see that the gaps here are clearly not linear. We know this isn't a linear function, it's a trigonometric function. But what they're interested in the next part of the question is to find the standard deviation of these entries. So if we think about the mean of these entries, well, they all cancel each other out. The mean voltage is 0, so the average voltage over the first 0.02 seconds, the first period, is 0. But what about the variability, how far away from the average is each entry? So the average is 0, but how far away is 156 from 0, and 269 from 0, and minus 156 from 0? That's called the standard deviation. So we do that in our calculator. We can see that it's 220. So the mean is 0, but the standard deviation is 220 in this question. So if we go to the voltages, and in our calculator we're going to select 2, statistics mode, to find the standard deviation. We're going to click on one variable. We're only measuring voltage. We're not measuring two things against each other. We're going to enter the data. We are then going to press 2, one variable calculation, and we're going to select the standard deviation symbol, which is this here. And the standard deviation is 219.89, which we said we'd round up to 220. So that's the standard deviation in the question. Remember, standard deviation measures the variability or the spread of the data. Even though the mean is 0, it has a spread, or let's say not a spread, but a standard deviation of 220. On average, that's how far each of the numbers was from 0. So to the final two parts, which people did find tricky, but what's important to realize is if we look at the marking scheme here, 5C, 5 marks for part 1 and 2 together. This was not a question that was answered well. Most people found this tricky to interpret what they were being asked. And it's not actually overcomplicated if we can break it down. What we're told is that the standard deviation of closely spaced values of any function of the form the voltage equals A sine bt. So basically in our question we had very closely spaced values. Our values were, so here's the period here, they went from 0 to 0.02. Now 0.02 is a very small number, and we had very closely spaced values where we found let's say, the outputs of the voltage. So they were very close together over this period. We found the standard deviation of those voltage outputs. And then this formula says that when you do that, there is a constant K that when multiplied by the standard deviation is always equal to the maximum voltage. So in our question, what we're saying is that there is some constant that we have to figure out. When you multiply it by the standard deviation of the values, 220, that will be equal to the maximum voltage, 311. Well, it's very, very easy to figure out what this constant is. This constant is 311, extra one, 311 divided by 220. And 311 divided by 220 is 1.414. And this is the constant for every sine function. So where we have a sine function like we've seen here, where it goes up and it comes down, it goes up again. And if our values have been closely spaced together, and for every function, if you multiply this constant, 1.414, by the standard deviation that you get, that will always be equal to the maximum voltage in the question. So it's just an interesting result. It's a result that's true for all sine functions, not something that a maths teacher would be expected to know, not something certainly a student would be expected to know, but it's this process of the examiner teaching you something through assessment. And there's a constant, 1.414, and it is always that number that when you multiply that by the standard deviation, you will get the maximum voltage of that particular function. Okay, so just to show that answer again, I manipulated the formula at the start. I said, well, the constant is going to be the maximum voltage divided by our standard deviation, and we get 1.414. Now we're going to use this result then to go and find out the formula V equals A sine BT. So we're going to find the A and B for which there's 60 complete periods in 1 second. Now remember, in our example, there was 50 complete periods in 1 second. And the approximate value of A, so that the standard deviation is 110. Remember, our standard deviation was 220. So we have a formula here, V equals 311 sine 100 pi t. And we want to make a formula where the standard deviation is 110 and there's 60 complete periods, as opposed to a standard deviation of 220 and 50 complete periods. So how are we going to do this? Well, to find the period, first of all, we're going to call the period 2 pi over the letter beside the t, which is b. And we want there to be 60 periods. So 2 pi over b is going to have to be equal to 1 over 60. 2 pi over b is equal to 1 over 60. Or the way we could write that is, how many 2 pi over b's is there in 1 second? Well, there's 60 of them. That's the same thing. So 2 pi over b is equal to 160. We'll invert that and we'll say b over 2 pi is equal to 60. So we take this, we can turn it all upside down and say b over 2 pi is equal to 60. So b is equal to 120 pi. Now a lot of people might have done that without the formula more intuitively. They would have said, maybe looking at our previous example, we have 100 pi and there was 50 complete periods in a second. Well, what if you had 60 periods? Well, if 50 periods is 100 pi, well then 60 periods is clearly 120 pi. So some people might have looked at it like that. If we wanted to do a formula, we could have done it this way. And the next thing is we want to find obviously the b value. And so we're going to use this formula here. K by the standard deviation is equal to the b max. Well, k is always 1.414. We've established that for this type of a sine function. So the constant is 1.414. We worked it out in the last one, but it's always true for all sine functions. It tells us that in the question. And if we multiply that by sigma, so sigma being the standard deviation, 110, that will give us the maximum. So 1.414 times 110 gives us the maximum. So let me take out the calculator and go ahead and do that. And we get 155.54. And sorry, the b value, I forgot to just actually multiply 120 by pi, so it's 377. So a is equal to 155.54. Now they don't ask us to, they just ask us to find a and b. They don't ask us to actually write the function, but the function would be 155.54 by the sine of 377t. Or we could say, let's round it off, 156 by the sine of 120 pi t, if we wanted to keep the pi notation into it. Okay, so look, most of the question is fairly straightforward. It was a little bit actually tricky to find the intervals we needed to use to make the table and come up with the values, but finding the standard deviation of the values was very easy. Finding the range was easy, but this last part was tricky to understand, tricky to interpret, but only worth 5 marks for both parts of this question added together.